Dear student, welcome to my classroom. In this class, we are going to prove Pythagoras theorem, which is very important in this chapter. So, before going to Pythagoras theorem, we need to introduce another theorem which helps us in proving Pythagoras theorem. And the theorem is, if a perpendicular is drawn from the vertex of the right angle triangle to the hypotenuse, then the triangle on both sides of the perpendicular are similar to the whole triangle and to each other. This is the theorem. So, uh, take a triangle ABC in which angle B is right angle, and now draw a perpendicular from B to the hypotenuse AC. Here the BD is perpendicular drawn from B on hypotenuse AC. Now, in triangle ADB, consider the triangle ADB and the whole triangle ABC. One part of the triangle ABC is triangle ADB and the whole triangle is ABC. So, by considering these two triangles, we can notice that angle A is the common angle in both the triangles. Isn't it? Angle A is the common angle. And in these two triangles, the right angle is at B and D. So that we can write angle ADB is equal to angle ABC. Both are equal to 90 degrees. So by angle similarity, we can say that triangle ADB is similar to triangle ABC. That is, the triangle on one side of this perpendicular is similar to the whole triangle. Now, take the second one, that is on right side of this perpendicular. So, triangle BDC. So, this triangle BDC is also similar to the whole triangle ABC. So, we can show similarly in this way. So, triangle BDC similar to triangle ABC, take it as equation 2. So, from equation 1, we have triangle ADB is similar to triangle ABC. And from second one, we have triangle BDC is similar to triangle ABC. So, from these two, we can write triangle ADB is also similar to triangle BDC. Okay. So, hence we proved the theorem that if in a triangle, if perpendicular drawn from the vertex on hypotenuse, then the triangles on both sides of this perpendicular are similar to the whole triangle and also they are similar to each other. So, we need to remember this theorem while solving Pythagoras theorem. Okay. So, now let us prove Pythagoras theorem, and which is also called Bodhin theorem. Bodhin is an ancient Indian mathematician. Before Pythagoras, he proved this theorem. So, and the theorem is, in a right angle triangle, the square of length of the hypotenuse is equal to the sum of the squares of lengths of the other two sides. So take a right angle triangle ABC in which angle B is equal to 90 degrees like this. Now, the result to prove is AC square is equal to AB square plus BC square. Here it is given that the square of length of the hypotenuse, that is square of AC, is equal to the sum of the squares of lengths of the other two sides, that is square of AB plus square of BC. So that is, we have to prove that AC square is equal to AB square plus BC square. To prove this, we have to make a construction that draw a perpendicular from B to the hypotenuse AC. That is BD perpendicular to AC. Now, in proof, we have triangle ADB is similar to triangle ABC. As we have proved in earlier theorem, the triangles on both sides of the perpendicular drawn from the vertex to hypotenuse are similar to the whole triangle, and also they are similar to each other. So that we can write triangle ADB is similar to the whole triangle ABC. And from this, we can write the ratio of corresponding sides is equal. That is AD by AB. Here, the AD is the side of the base of the triangle ADB, and in the triangle ABC, the base is AB. So AD by AB is equal to, in the whole triangle, in the second triangle, the hypotenuse is AB, and in the whole triangle, the hypotenuse is AC. So the ratio of hypotenuse is AB by AC. That is, we can say that AD by AB is equal to AB by AC. So from this, we can write AB square is equal to AD into AC. So take it as equation 1. Now consider triangle BDC and ABC. Now the second triangle on which is the side of perpendicular BD is triangle BDC. We know that it is also similar to whole triangle. That is triangle ABC. So triangle BDC is similar to triangle ABC. Now, from the ratio of corresponding sides, we can write CD by BC. Here the base is CD, and in whole triangle base is BC. And in this small triangle, hypotenuse is BC, and in the whole triangle, hypotenuse is the AC. So BC by AC. CD by BC is equal to BC by AC. And from this, we can write BC into BC is BC square is equal to CD into AC. Take it as equation 2. Now, by adding these two equations, we get on right side, AD into AC plus CD into AC is equal to, on left side, we get AB square plus BC square. Now, in these two terms, we have AC common. So take AC common. Then we get AD plus CD into AC is equal to, on the right side, we have AB square plus BC square. But from this figure, we have AD plus CD is equal to AC. So from this, we can write AC into AC is equal to AB square plus BC square. And from this, we have AC square is equal to AB square plus BC square. So which we require to prove. So in a right angle triangle, square on the hypotenuse is equal to sum of the squares of on remaining two sides. So hence we proved the theorem. And now let us prove the converse of Pythagoras theorem. That is, in a triangle, if the sum of the squares of two sides is equal to square of the hypotenuse, then the triangle is right angle triangle, and the angle opposite to the hypotenuse is right angle. So that is the converse of Pythagoras theorem. So here the statement is, in a right angle triangle, if the square of length of one side is equal to the sum of the lengths of the other two sides, then the angle opposite to the first side is a right angle, and the triangle is a right angle triangle. This is the converse of Pythagoras theorem. So let us prove that this theorem. So take triangle ABC, in which angle B is 90 degrees. Sorry, we have to prove that. Take triangle ABC and consider that AC square is equal to AB square plus BC square. And we have to prove that angle B is equal to 90 degrees. So in construction, construct a right angle triangle PQR, right angled at Q such that PQ is equal to AB and QR is equal to BC. Okay, now we are constructing a right angle triangle PQR such that AB is equal to PQ and BC is equal to QR, in which angle Q is equal to 90 degrees. Now, let us prove the theorem. In triangle PQR, we have PR square is equal to PQ square plus QR square. So, because of Pythagoras theorem. But we have PQ is equal to AB and QR is equal to BC. So, from these two, we can write PR square is equal to, instead of PQ, we can write AB, and instead of QR, we can write BC. So that PR square is equal to AB square plus BC square. So by construction, here we are writing PQ is equal to AB and QR is equal to BC. So take it as equation 1. Now, but it is given that AC square is equal to AB square plus BC square. So take it as equation 2. From these two equations, we can notice that both PR square and AC square are is equal to AB square plus BC square. So we can write PR square is equal to AC square, and that is AC is equal to PR. Now consider triangle ABC and triangle PQR. We have PQ is equal to AB, QR is equal to BC, and we proved that PR is equal to AC. That is, the sides of the triangle ABC are is equal to the sides of triangle PQR. So by triplets congruency, we can write triangle ABC is similar to triangle PQR. And we know that in congruent triangles, corresponding parts are equal. So that angle B is equal to angle Q because of CPCT. That is, corresponding parts of congruent triangles are equal. So, but we have angle Q is equal to 90. So angle B is equal to angle Q and angle Q is equal to 90 degrees. So that angle B is equal to 90 degrees. So this is the converse of Pythagoras theorem. So converse of Pythagoras theorem is saying that in a triangle, the square of the length of one side is equal to the sum of the lengths of the other two sides. The angle opposite to the first side is right angle. Okay, hence proved. So using these two theorems, now we are going to solve the problems in exercise which are based on Pythagoras theorem. So let us start the exercise 8.4. The first one, prove that the sum of the squares of the sides of a rhombus is equal to the sum of the squares of its diagonals. So sum of the squares of the sides in a rhombus is equal to the sum of the squares of its diagonals. So take a rhombus ABCD in which its diagonals are intersecting at O. Here is the ABCD is rhombus and its diagonals AC and BD are intersecting at O. Now, as it is a rhombus, we have AB is equal to BC is equal to CD is equal to AD, isn't it? And also angle AOB is equal to angle BOC is equal to angle COD is equal to angle AOD is equal to 90 degrees, because in a angles, diagonals bisect each other perpendicularly. Now, in triangle AOB, we have angle AOB is equal to 90 degrees. So by Pythagoras theorem, AB square is equal to OA square plus OB square, because in a right angle triangle, we know that square on the hypotenuse is equal to sum of the squares of remaining two sides. That is, AB square is equal to OA square plus OB square. Similarly, in triangle BOC, BC square is equal to OB square plus OC square. And in triangle COD, CD square is equal to OC square plus OD square. And in triangle AOD, AD square is equal to OA square plus OD square. because all these four are right angle triangles, and we are applying Pythagoras theorem for each triangle. Now take the sum of the squares of the sides, that is AB square plus BC square plus CD square plus AD square. Sum of the squares of the sides is equal to, we have AB square is equal to OA square plus OB square, BC square is equal to OB square plus OC square, CD square is equal to OC square plus OD square, and AD square is equal to OA square plus OD square. So substitute all these four values in this expression, that is AB square is OA square plus OB square, BC square is OB square plus OC square, CD square is OC square plus OD square, and AD square is OA square plus OD square. There are two OA squares, two OB squares, two OC squares, and two OD squares are there. So the sum is 2 into OA square plus OB square plus OC square plus OD square. And we know that in rhombus, diagonals bisect each other. That is, both OA and OC are equal to half the AC, and OB and OD are equal to half BD. So now substitute OA is equal to half AC, OB is equal to half BD, OC is equal to half AC, OD is equal to half BD. So OA is half AC and square is also there. And in each term, we were substituting, that is half the diagonal. So now we get 2 into, each term is 1 by 4 AC square, 1 by 4 BD square, 1 by 4 AC square, 1 by 4 BD square. So we are taking 1 by 4 common. Then we remains with AC square plus BD square plus AC square plus BD square. Now 2 into 1 by 4 is 1 by 2. And there are 2 AC squares and 2 BD square, and the sum is 2 AC square plus 2 BD square. Again, take 2 common and cancelling a numerator and denominator, which remains with AC square plus BD square. So that is the sum of the squares of the sides is equal to sum of the squares of diagonals. Here we know that AC and BD are the diagonals. Okay. So take next one. ABC is a right angle triangle at B. Let D and E be any points on AB and BC respectively. Prove that AE square plus CD square is equal to AC square plus DE square. This is the figure given in textbook. So in this triangle ABC, angle B is 90 degrees. D and E are the points on AD, AB and BC respectively. Now we need to prove that AE square plus CD square is equal to AC square plus DE square. Okay. In this figure, we have 4 right angle triangles. First one is ABC. Second one is DBC. Third one is DBE. And the whole triangle is A. And also there is ABE. So 4 right angle triangles are there. And we can apply Pythagoras theorem for each of these triangles. So given angle B is equal to 90 degrees. And now first in the whole triangle ABC, AC square is equal to AB square plus BC square because of Pythagoras theorem. And take the triangle ABE. In triangle ABE, AE is the hypotenuse and B is right angle. So we can write AE square is equal to AB square plus BE square. And now take DBC, right angle triangle DBC. DC is the hypotenuse. So that square of the hypotenuse, that is CD square is equal to BD square plus BC square. And now this small triangle DBE is also right angled at B. So that we can write DE square is equal to BD square plus BE square. Now take the LHS, AE square plus CD square. A square is equal to AB square plus BE square. CD square is equal to BD square plus BC square. Now substitute these two values in this one. Now by rearranging these terms, we can write AB square plus BC square as one group and BE square plus BD square as one group. We are rearranging these terms AB square, BC square as one group and BE square and BD square as one group. But here we have AB square plus BC square is equal to AC square and BD square plus BE square is equal to DE square. So we can replace with AB square plus BC square by AC square and BD square plus BE square by DE square. So which is our required RHS. So that LHS is equal to RHS. Okay, LHS is equal to RHS. So let us solve the next problem. Prove that 3 times the square of any side of an equilateral triangle is equal to 4 times the square of the altitude. That is, an equilateral triangle, 3 times the square of the side is equal to 4 times the square of the altitude. That is, we have to prove here. So take an equilateral triangle ABC in which each side is equal to BC. So each side is equal to A and the length of altitude drawn from the vertex to the base is AD is equal to H. So right first in an equilateral triangle ABC, AB is equal to BC is equal to AC is equal to A and the length of altitude drawn from A and BC is AD is equal to H. Now consider the triangle ADB and ADC. There is both triangles of which are on the side of altitude, ADB and ADC. In these two triangles, we have angle ADB is equal to angle ADC is equal to 90 degrees because here AD is the altitude. And also we have AD is the common side and AB is equal to AC because triangle ABC is equilateral triangle. Now, in these two right angle triangles, we have hypotenuse are equal and one side are equal. So, by RHS congruency, triangle ADB is congruent to triangle ADC. Okay. Triangle ADB is congruent to triangle ADC. So, from that we can write BD is equal to CD. That is altitude divides the opposite side into equal parts. So, BD is equal to CD is equal to half the A by 2. Now, as ABD is a right angle triangle, by Pythagoras theorem, we can write that AB square is equal to AD square plus BD square. So we are applying Pythagoras theorem for this right angle triangle ADB. So AB square is equal to AD square plus BD square. Now substitute AB is A, AD is H, and BD is A by 2. So from this we can write A square is equal to H square plus A square by 4 and A square minus A square by 4 is equal to H square. By simplifying, we get 3A square by 4 is equal to H square. That is 3A square is equal to 4H square. That is 3 times the square of the side is equal to 4 times the square of the altitude in any equilateral triangle. Okay. So take the next one. PQR is a triangle, right angle at P, and M is a point on QR such that PM perpendicular to QR. Show that PM square is equal to QM into MR. So we solve this problem using the theorem which we have proved in earlier of this class. So in triangle, take in triangle PQR, it's given that angle P is equal to 90 degrees and also PM perpendicular to QR like this. So here PM is perpendicular drawn from P on the hypotenuse QR. So the triangles RMP and PMQ are similar to each other because we proved this result in first theorem. So as triangle RMP is triangle PMQ, now the corresponding sides PM by QM is equal to MR by PM. PM by QM is equal to MR by PM. So from this we can write PM square is equal to QM into MR. So hence we proved the result. So take next one. ABD is a triangle, right angle at C, right angle at A, and AC perpendicular to BD. Show that AB square is equal to BC into BD. AC square is equal to BC into DC. AD square is equal to BD into CD. So we prove all these results like earlier problem. So here it is given that triangle ABD is right angle at A and AC is perpendicular to BD. Okay. So as AC is perpendicular to BD, now the triangles on the side of this hypotenuse both are similar and also they are similar to whole triangle. Okay. So that is angle triangle BCA similar to triangle ACD similar to triangle BAD. Okay. We proved already this point. Now take triangle BCA similar to triangle BAD. And as these two triangles are similar, ratio of corresponding sides is equal. So that AB by BD is equal to BC by AB. So from this we can write AB square is equal to BC into BD. Also second one is also same. Triangle BCA similar to triangle ACD. From that we can write AC by DC is equal to BC by AC. And the second one we get. So now in third one, BAD is similar to ACD. This is also same. Okay. So let us solve the next one. ABC is an isosceles triangle right angle at C. Prove that AB square is equal to 2AC square. So here ABC is an isosceles triangle right angle at C. As angle C is equal to 90 degrees, AB is the hypotenuse and the remaining two sides are equal. So that AC is equal to BC like this. So ABC is right angle triangle in which angle C is equal to 90 degrees. So as hypotenuse is a longer side than BC and AC, we can take that AC is equal to BC because an equilateral triangle in an isosceles triangle, two sides are equal. Now, as triangle ABC is a right angle triangle, then by Pythagoras theorem, square on the hypotenuse, that is AB square is equal to AC square plus BC square. But here we have AC is equal to BC. So we can substitute AC in place of BC. Like this. Now AC square plus AC square is equal to 2AC square. So AB square is equal to 2AC square. So hence proved. Okay, students, that's all for today. And in next class, we solve the remaining problems in this exercise. Until then, see you. Bye.